So yesterday we have seen, we started actually 1G. Okay, so the fundamentals of 1G. Okay, so before discussing 1G, we have gone through what exactly the frequency is, what exactly the bandwidth is. Okay, so UL bandwidth and DL bandwidth, right? The channel bandwidth. Okay, channel bandwidth, or you can say carrier bandwidth. Apart from that, we also seen that, right, exactly frequency operation, then human voice, how it is converted. So the main thing is, okay, the main thing why we are using 800 megahertz, 900 megahertz, 2100, 2300, right? Why we are using this frequency means like to transmit the signal to a longer distance. To transmit the signal to a longer distance. Okay, longer distance, right? To transmit the signal longer distance. Always, right? Two things remember. Okay, coverage depends on two things. Coverage, coverage depends on, right? One thing is power, how much power you are feeding to your antenna. Okay, the second thing is height of antenna. Right, height of antenna. So if 120 meters tall tower may gives you 15 to 20 kilometers of coverage. Of course, olden days we used to use these 120 meters tower, but now, right, the coverage, because capacity can be increased. Capacity can be increased by reducing the coverage, by reducing the coverage, or you can say by reducing the tower height, right? I can create the holes like this. I can create, I can create space. Then I can install one more tower.
So, sir,
So,
1 minute. So,
hmm,
how you are calculating? That means 120-meter tower height means it will go.
no, no, this is an example. I am not telling you.
Oh, example. Okay.
Example means like, see, if I have 10 meters antenna, right, then definitely I cannot directly calculate. There is a softwares, okay? There will be softwares. So those will calculate. My intention is to tell you power and height of antenna can increase or decrease the coverage. Okay.
Mm-hmm.
That's what I wanted to tell you. So I am,
Okay.
this is not a exact, okay?
Okay, sir.
Okay, right. So this means like, so to cover the larger distance, right? So we are going for the higher frequencies, right? A lower antenna height. If we wanted to transmit lower frequency for longer distance, this is uh, not possible. And we have seen yesterday. So that is, here it is. That's why we go for the modulation. Okay. We cannot transmit this 3 kilohertz to 3 to 4 kilohertz of frequency to a longer distance. That is not at all possible. Okay, possible, but by building the, 2 kilometers or 3 kilometer antenna. So right, vertically that is not possible. So that's why we are going for higher frequencies, so which can travel right a little longer distances. Okay. So apart from that, we have seen, right, 1G, right, the fundamental is, right, fundamental technology is frequency division, multiple access frequency division, multiple access. Okay. Frequency division, multiple access. Right. So how multiple UEs or multiple devices are able to communicate with the, right, with a single base station, right? So this FDM, PDMA, CDMA, OFDMA, right, help to communicate many users with one base station. So similarly, frequency division, multiple access we have seen, right? Whereas AMPS brought this once where, guys, okay, 1G services brought by the AMPS, okay, 1G services brought by the AMPS, right? Where 25 megahertz have right assigned to the amps, then the channel bandwidth is 30 kilohertz, right? This 30 kilohertz totally will get the 832 channels, right? 832 channels, which means, right, one channel, or you can say one channel per one user. So definitely this is not a good design. But it is a great design in 1980s, great technology, you can say great technology, but not a good design. Okay. Or else one user per one channel, one user per one channel, right? Definitely not a great technology in 1980s, but right, not a good design. So then people thought, right, people have taken more and more connections, more and more connections. Then this 1G was not able to handle, 1G was not able to handle the right to traffic because of one user per one channel. Then people thought, so means especially here, channel allocation, right? Channel allocation is done. Channel allocation is done in terms of frequency. Okay, in terms of frequency, channel allocation is done in terms of frequency. So frequency is so costly. Then people thought that, right, spectrum is costly. Then why can't we assign? And here the major drawback in FDMA, right? If one channel, this is 24, right? Let us take time domain and frequency domain. If a channel is assigned to a user, right? User, if he wanted to use entire time, means 24 hours if he wanted to use, right? 24 hours, this channel will be in use. So that is the drawback. No one can use 24 hours. If a person wanted to use that channel, then this channel will be in use for 24 hours. That is the major drawback. Means no one can use it. So that is the drawback. So people thought that instead of assigning the frequency to a single user, why can't we assign this to a limited time? Here 24 hours, right? So why can't we assign the channel at limited time? Limited time. So this thought, right, brought the TDMA into picture. Okay. There is a technology called North American TDMA. So as per the TDMA, means channel allocation is done. Channel allocation is done in terms of time domain. Time domain. So what do you mean by time domain? So for example, this same frequency, right? Here it is 20, then frequency, right? The same channel, right, was divided into 8 slots. Okay, slot 0, slot 1, 2, 3, 4, 5, 6, and 7. So now this is the same frequency, channel bandwidth, same channel bandwidth, but right now 8 people. So if I can say this is the base station channel. So now here I can say user 0, user 1, user 2, user 3, user 4, user 5, user 6, user 7. So which means North American TDMA is a digital technology, right? Digital. So digital means you can say discrete. Discrete means like purely 1G, purely 1G is an analog communication. Communication should be continuously happen. There should not be any right distraction. Communication should be continue in time domain. But here it is, communication is discrete in time domain. Means, for example, user 1 can transmit its voice here, right after 7, again user 1, user 0. Okay, after that user 1, which means, so first data of voice, right, some of the voice can be transmitted by this fellow here and here. Okay, and somewhere again here, and so on. Means you can see some part of the data, some part of the voice is transmitting here, right? But no voice transmission in this gap. Again, voice transmission is happening here. Again, voice transmission is happening here for this user 0, user 0. So which means this is called a discrete transmission. Discrete transmission means there is a small gap of time. So you can say 577 microseconds into 8. So somewhere around 4 milliseconds. So means data will be transmitted for a UE at every 4 milliseconds. For every 4 milliseconds. It is a discrete, not a continuous. Means this user data is transmitted here, 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 and so on. But the beautiness of this discrete communication, even though discrete means discontinuous voice. Discontinuous voice transmission. Okay. Discontinuous voice transmission. Even if it is a discontinuous, right? But the right, let us take 4 milliseconds. So our ear and eyes, right, all senses cannot identify the millisecond difference. So when the voice reaches us, by using this technology, but our ear cannot identify the milliseconds and microseconds difference, so that we feel that data is happening continuously. Even though internally data is not continuous transmission, it is a discrete transmission, but our ear feels that data is in continuous transmission. Okay. So now this invention, discrete, because of the digital technology, because of discrete in nature and discontinuous in voice, right? This has helped a lot to transmit the data, to transmit the multiple users data by using a single frequency, single channel. Right now, right, this is one channel, but now I am able to use to transmit the 8 users data. So simply I can say, if this is my right frame, then user 0, 1, 2, 3, 4, 5, 6, and 7. So same channel bandwidth, right? In pure 1G analog, I was able to transmit only one user data. But now, right, I am able to transmit same bandwidth, channel bandwidth, I am able to transmit 8 users data. Got my point? Now I am able to use to transmit 8 users data. Definitely here channel capacity or bandwidth, the capacity has increased over 1G. Am I correct or not? Hello?
Yes,
Yes, it's
So means like almost 8x. I am able to increase the capacity 8x. Okay. I'm able to increase the 8x. So this invention, right, along with the FDMA and TDMA, right, they have started designing the GSM, right? Here it is FDMA plus TDMA. Okay. FDMA plus TDMA. So simply I can say again, when it comes to this is the time domain, means like I am increasing the capacity of the network to, right, serve the more and more people. With 1G, I was not able, only one channel, one user per one channel. Where great technology, but good design, not a good design. TDMA is somewhat okay. Then with the help of FDMA and TDMA, they have built. Means like, again, GSM is purely digital. Okay, wherever there is a time domain channel allocation involved, wherever there is a channel allocation in time domain, those are all digital communications, okay, which is discrete in time domain. Okay, so digital purely. Then for the GSM is a combination of FDMA and TDMA. So I can simply say the total bandwidth assigned to these GSM services, again 25 megahertz. But right, this is huge to transmit the human voice, right? We have seen 25 megahertz is right. So human voice is 3 kilohertz to 4 kilohertz. Even after modulation and digital playing. Oh, digital means what? Zeros and ones, right? Zeros and ones. So to provide the security, if let us take, if some bits are, once I say hello, once I said hello, it is produced some bits. To do security, right? Some manipulation will be done with the zeros and ones, right? All computers, algorithms makes the right data jumble. If anybody wanted to catch 1G analog, right? If anybody wanted to tune to particular frequency, they can hear all the voice, right? In communication. They can listen each and everything. But when it comes to GSM, little tough, because we are manipulating with the zeros and means like, right, we can play with, right, we can misguide the who wanted to catch the voice. So that is the beautiness. So even though 3 to 4 kilohertz, but little, right, after manipulating, adding additional bits, right, that may be little higher bits, but 25 megahertz is far, means huge bandwidth compared to this. Okay, so that's why this 25 megahertz is further divided into channel bandwidth. Here the channel bandwidth is 200 kilohertz. Okay, 200 kilohertz because of the digital in nature. Okay, I will show you like how things will happen here. So totally we used, right, we got 125 channels, right? We used to call these are ARFCNs, absolute radio frequency channel numbers. Okay, ARFCNs, absolute radio frequency channel numbers, right? Actually total 125, but one is given for the God band. So GSM, right? If I can say, this is my GSM frequencies. So this may be used for some other services. This may be used for some other services. Definitely to reduce the interference, right? We need a God band. Okay, God frequency. So, right, total after this, total 124 are available. So out of this 124, companies used to purchase depending on their capacity. Companies purchases, right? For example, ARFC in 53, 55, right? So depending on the requirement, companies may purchase. Like let us say BSNL might have right, maybe 7 channels or 19 channels, depending on the company capacity, right? When GSM was there, so many operators was there. Tata Docomo was there, even BPL Mobile was there, even many mobiles was there, right? They used to take. So which means my total bandwidth is 25 megahertz, but my channel bandwidth is, I hope you are able to follow me, right? 200 kilohertz. Okay. Each of which is 200 kilohertz. Right. And so on. Total 124. 1 to 124 of the channel. So definitely the beautiness. So this is right frequency. This is the frequency axis divided. So FDMA is done. Then TDMA. Right. Each and every frequency is further divided into 8 slots. Slot 0, slot 1, slot 2, slot 3, slot 4, slot 5, slot 6, slot 7, slot 8. So this 8 slots, we are calling it as a frame. Okay, I'm introducing you slot concept and frame concept, right? Further, we will, this will continue, right? 4G, 5G, this slot concept. And so user 0, user 1, user 2, user 3, user 4, user 5, user 6, user 7, then user 0, and so on. This will continue. Okay, so this is slot 0, slot 1. So instead of writing this, I'll take another. Okay, slot 0, slot 1, slot 2, slot 3, slot 4, slot 5, okay, slot 6, slot 7, slot again 0. So which means simply I can say slot 0 is assigned to slot, right? If I assign this frequency, right, channel number 1. So channel number 1 is given to this base station, channel number 2 given to this base station somewhere, channel number 3 given to this base station, means like you can say channel number 1, channel number 1, channel number 2, just example, channel number 3, which means each and every channel, each and channel number 1. So here, so 8 slots, I can say. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So here also this channel 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Which means you can see in 1G per one channel, one user. Now, right, per one channel, right here, 8 users per channel. Okay, 8 users per channel. So definitely I can say the capacity has increased. 8 users per channel. 8 users per a channel. 8 users per channel. Okay. I hope you got it right, how capacity has increased and channels will be assigned like this. And here the slot duration is 577 microseconds, very smaller, and frame size is 577 microseconds into 8, because 8 slots. So means the user 1 data is repeating here. User 1 data repeating here. Now let us take my user has said hello. So this is analog. Actually, when we say hello, that is analog. This will be converted to digital, analog to digital. Let us take this has produced 1000 bits. Okay, 1000 bits. So this 1000 bits cannot transmitted in a one slot. So in GSM, 114 bits can be transmitted in one slot. 114 bits can be transmitted it in one slot. Okay. So additionally some other bits are also there, right? So which means to transmit the 1000 bits, how many divisions I'll get? So 8, almost 9 divisions, means your data means first 114 bits will be transmitted here, next 114 bits will be transmitted here, next 114 bits will be transmitted here somewhere. Okay, next 114 bits means like user 0, user 0, means here 114 bits, here 114 bits, here 114 bits, means like this, right? User hello message, user's hello message is going to transmit like this, means 9 frames it takes. So this is first frame, right? Next frame started here, next frame started here. So simply I can say to transmit this 1000 bits, there is a need for the 9 frames. Example I'm saying. Let us take example. If it is produced, if it produced more bits, more number of frames. But what is the time time of each frame. What is the time of each frame? It is for around 4.3 milliseconds. Very smaller time. As a human being, we don't identify, but machines, 4.3 milliseconds or seconds are very um, important to the machines, but not humans, right? We don't, because we don't recognize the microseconds and milliseconds difference. So data will be transmitted like this. Okay, right? Slot, then frames means data to transmit the hello voice, right? We need at least 9 frames. I hope you got it right.
Yes, yes.
Right. So this way data will be transmitted. So this is the digital way of transmission. Okay. So let me show you how data transmission will happens. So like that, even though it is a digital, but we don't recognize. Okay, machines, but machines can recognize. So how data transmission will be there. Okay, so here it is, data transmission. Okay, so here it is the 8 users. Okay, so this is my frame. Okay, this is my frame, right? Internally, these are all slots. Sorry, where it is. Okay, so this is slot 1, 2, 3, 4, and these are all slots. So these are all number of slots required to transmit. Okay. So 3 kilohertz voice will be digitized at 13 kilobit, means A to D, analog to digital, right? So this bits will be, for this user, bits will be pushed here. For this user, bits will be pushed here. For this UE, means like data will be filled in slots. Then these slots make frames. This slots will be converted into the frames. Then these frames in GSM especially, these frames will be right converted into multi frames, and these multi frames will be transmitted, because right my channel bandwidth is 200 kilohertz for per one bit per one hertz, one bit per one hertz. So then, which means around 200 kilohertz, kilobits per second I'll get. Okay, so means 200 kilohertz is required to 200 kilobits, means digital data. So, but there is a modulation, right? GMS came, then total with the multi frames. You can see slots of frames, multi frame, right? 26 multi frames. 26 multi frames. Data rate is 270.8 kilobits per second. But after applying modulation, right? So there is a GMSK, QPSK, 16 QAM, 64 QAM. So these are the modulation schemes actually. Okay. So then this becomes 200 kilohertz, and data will be fit into the 200 kilohertz. So this is the basic principle of GSM operation. Okay. So apart from that, right, there is a frequency hopping concept, right? I am introducing hopping here itself. So means user can jump is transmission, data transmission in a different frequencies. So this is right. If this is optional technology, right? Right, to misguide the intruder. If somebody wanted to catch the signal, then we can by doing the frequency jumping in while transmission, jumping in frequency can make a security, high security, means like if somebody wanted to tune to the frequency, he cannot identify where data is transmitting exactly. So this is one feature of a GSM. Just have a look on it. I'll come back in a minute. Right. I hope you got it right. The operation of GSM.
Yeah, correct.
See, I suggest you please take two books, okay? Two notebooks. So you write become a school student, right? You become a school student like 10th or 12th standard, okay? Then only you can able to learn, right? Even though right you are grown, but become a student, you take two notebooks, okay? Buy two notebooks until unless you learn like a kid, you cannot get a you cannot get through interview. Trust me, okay? So buy two books. One is the you can say classwork and homework kind of thing. Okay. So you write whatever I am saying, whatever I am teaching, running notes like, right? Later on, whenever you get a time, you go and sit, right? You prepare good notes, which means don't copy paste, right? You understand the concept and write in your own words, right? If you copy paste, then it has to read like a textbook. So, right, you have to read all the pages and all the concepts again and again. But if you written in terms of your own words, right? So this homework kind of thing you should write. Now today we have discussed the GSM. What you understand, you make it a point. GSM is a slot based communication, digital communication, slot based. Then each slot is assigned to a user, right, which is of 577 microseconds. Simple, right? Very simple, right? So each slot will be given to one user, right? Total eight slots becomes one frame. So this kind of points you should note down. Whenever you wanted to refer the notes, whenever you are attending interview, just write a bird eye view means like just going through pages, you should be able to understand and you should able to give the interview. If you are writing like a Ramakoti, then it will be a copy paste. If you are doing a copy paste, then it will take a lot of time. You will not able to prepare the interview. If tomorrow interview, just you should go through page by page within hours. If you are right going through slowly through all the entire book, then that is not good because already matter is there in videos. If you copy paste, that will not help you. You try to understand the concept and write in your own words. Okay. I hope you got it right.
Yes,
Until
sir.
unless you become a kid in this course, you will not succeed. Trust me. You take the notebooks first, right? At least if not today, at least tomorrow you purchase two notebooks, write a little longer, big notes. Okay, right? You start writing. Okay, otherwise today you will listen, tomorrow you will forget. After 1 month, if I ask something, then you cannot get it. Okay, until unless you become a kid, you cannot learn. Okay, even though you know. Right, and trust me, many of you are not aware of perfect concept, even though you are working in LT or 5G some, right? I'll teach you the perfect subject. If you know the perfect subject, you can handle any kind of interview, senior level, junior level, even architect level interviews. Just you can easily handle. It is all about confidence. Handling interview is all about confidence. Confidence comes from the subject. If you have good subject knowledge, you can handle any kind of interview. Trust me. Clear,
Yes, sir.
right? So purchase books and become a kid, right? You sit along with your kids, okay, and start learning. Fine. So this is about GSM, right? Once again, right here you can see 25 megahertz and guys, just a minute. Okay, right. So the band of operation or the frequency of operation is right here. It is mm, right. So these are the band of operation, right? Bandwidth is 25 megahertz, right? Total. Actually, if we divide this 25 megahertz with 200 kilohertz, we used to get 125, but one channel is for bandwidth, God band, then total 124 channels available. Okay. So this is for uplink, this is for downlink, right? There will be always in the uplink lower frequency, downlink higher frequency. Okay, because right there is again right uh, transmission distance depends on the frequency. So you can see 960 minus 935, right? You will get 25 megahertz here. Right here also 915 minus the 890 will give you 25 megahertz here also. Okay, so this is the band of operation in all LTE 5G, right? Depending on the frequency, depending on the band, right? It will look like this only, right? Right. So another I hope no doubts in this, because GSM is right. I can say LTE is derived from the GSM. Okay, GSM. Whereas 5G is derived from 5G is desired from 3G, right? Which is WCDM. Means not derived, but features built. Okay, similar. So features of 5G look like a 3G. Okay, so it is important to understand these concepts. Fine. I hope you got it right.
Yes, sir.
No doubts.
In ideal mode, UE latches
See, idle
according to this channel.
See, idle mode, okay, let me go through what do you mean by idle mode. So, mobile will be either in idle mode or connected mode. Okay, what do you mean by idle mode and what do you mean by connected mode? Okay, connected mode where data transmission happens, data or voice transmission happens. Right, when mobile is idle, right? No data transmission or no voice transmission. Okay, then when there is no data transmission, no data transmission, no voice transmission, no channel required. No channel required, right? So for example, you are traveling from place A to place B. Okay, when you travel, you use the road, right? When you are traveling, when you started traveling, you use this road. Place A, place B. If you are not planned to travel, then how you can use this? If you are not traveling, you don't use, right? Traveling, use road. Not traveling, not required. Correct?
Yeah.
So similar thing. When connected mode, right, to transmit the data voice, right channel is required. Channel required. Channel means slot required. Right, when idle mode, no data transmission, nothing. So no channel is required. So for example, if you take, even though when mobile is in idle, if you want channel, then for the one crore people, 1 crore connection, then we should have 1 crore channels. Is it possible? Not possible, right?
Mm.
So it is like a switching, right? We have seen switching concept. So what do you mean by the switching? We have seen landline. We have seen landline. So what is the fundamental concept there? Switching. Use the circuit when you require. On the circuit, establish the circuit when you want. If you don't want, release the circuit. Once call is disconnected, circuit will be disconnected, released, right?
Yeah.
Right. So from tomorrow onwards, please join little early. Okay. Little early means like by 8:05, so that we can close 5 minutes early. Okay, because all office times, right? Fine.
Yeah, sure.
So for now, I am closing the class. We'll see tomorrow.
Okay, sir. Thank you.